Hello, this is Professor Michael Labasi for Sinclair College, and this is a look at CIS 2808, Topic 9, which is investigating web attacks. And this is using the CHFI or Computer Hacking Investigator content. So this is normally, this would be at week 9 at the time of this recording, and this is, of course, the CHFI Volume 3, Chapter 2. So web attacks. So we just came off of talking about um, network analysis, and it's really going to apply a lot of the same aspects here, but we're going to look at some underlying things we need to pinpoint when actually investigating a web attack. So before we jump into this, there's a very good chance that you'll be in log files. So no surprise, right? Dealing with log files, especially with web attacks. And again, it's not like you're going to bring the system, turn it off, bring it into the evidence room, or or preserve it for a court of law. It's going to be an ongoing system. It might be put on like pause if it's a like a virtual machine types layout, like with cloud. But either case, it's very uncommon you're going to actually shut systems down and use them as evidence. You'll have a copy of the logs. So, and another thing to point out is there's a very good chance with this type of analysis, it's not going to be for criminal forensics. It's going to be more for an incident response for a team. So um, now, if we think that this might lead to a criminal, get the authorities involved, then you might want to make sure that your logs, of course, and this is going back to topic 8, log files as evidence. Again, admissibility of the logs could be crucial if it has to go to the authorities. So, um, criteria for examining logs evidence, their business records, they're of normal business practice, they're maintained regularly, and then they're in a sound manner. And if you do think it's going to happen, then yeah, make a forensic copy. You're given the log files from maybe from the provider, from the administrators. Make hash it, save it, and make a certified copy of it, and only investigate the copy and keep those as original. So no different than if you're dealing again with network-based attacks. So I just want to bring it up. This is from the last one, so the last topic, topic 8. So, but we're going to focus more on the web attack aspect of this. So, uh, you could probably guess it's going to have a lot of the same aspects of dealing with log file with network attacks. So this is just more an extension of that. So I don't want to dwell too much in the previous topic, but those same approaches are going to be applied here, and you'll see with the lab that it's in fact using the same tools, but what you're looking for are different indicators of the attack or indicators of compromise or attack indicators. So um, again, web application forensics, what is it in the first place? Well, websites, web activity. And we'll see that might go deeper than just what we think is the web server. And I'll have a graphic for that. But there are some challenges again. There's very little downtime allowed for websites, especially if this is a large corporate effort. Also, there's going to be a lot of analysis and correlation. So very and huge volume of logs. So that's something to consider too. Log files themselves might not be large disk-wise, but to parse through them could be very taxing. Um, if you don't have a good like Splunk system or something set up to parse logs, then you need to get one together. And it could be that um, the group you're working with maybe will have a spare server they can use to help you do this with. Or even if they have their own logging system, they might be able to set you up an account and then you can load those logs there and then leverage that CPU and memory to do the analysis. Um, but again, and this is the thing here. So it requires complete knowledge. This is complete knowledge. That's pretty depth. What that means too is you might need to be reaching out to administrators both in different areas. Now what we're looking at is web servers, application servers, and databases. So I have this here. I know. Look at this graphic here. There's a lot of components we got to consider here, and I'll use the red. First off, geographically, where the attack may have come from. I said because the attack could be a DDoS-based attack, which means it becomes distributed denial of service, hence distributed. But if the attack came in from a single source, um, there's a lot of components to this chain here. So first off, for security purposes, yeah, we have firewalls. So firewall logs are going to be of key, and there could be a firewall log back here. It depends how deep the attack goes, and it could be more than one here. You'll have IDS systems, possibly as intrusion detection systems. I'm going to look at that here on the slides. But of course, they're going to be great. They might be the ones to actually kick off the alert and allow people to shut down that traffic. And then you actually can maybe use this in part of your analysis. In fact, IDSs have some ways to help you pinpoint some of the metrics you need to pinpoint, origin of attack, attack type, things like that. So this could be your tool if it's possible, if you can leverage that tool um, to help you pinpoint this. So yes, web servers. This is definitely going to be probably one of the main things, and we'll look at the two main types. But something to consider is this. With a large system, traffic comes in, the attack comes in, hits the firewall, it gets through, and it could be the firewall itself could be a persistent-based, anomaly-based firewall. Maybe it's just session-based. So there could be some more here than just this. This is where there's a tie between these two here. The firewall and IDS could have a lot in common. In fact, the IDS could be on the firewall itself. But anomaly-based and pattern-based attacks. So what I mean is we have an IP address here that has sent a pattern of known attacks. So that traffic was shut down, but we have a log file showing it. We can probably see what they're trying to do. But there's things to consider here in place, and specifically especially with the cloud, you have something called load balancers here. Now they may or may not have logs, but that means the traffic comes in. It may be distributed to only one or two. If the session is cut and reestablished, it might actually go to a different one. So you have this sort of load balancing in play, and it could be round robin, it could be least first, things like that. There's different algorithms that load balancers will use. So understanding how the traffic is coming in means there could be logs, not just on one server, it could be on other web servers themselves. Now, you also might have a load balancer here behind it, which deals with the application servers. Now, these are the sort of the mid-tier servers that apply application logic, where the web server is going to serve content and handle the traffic, getting the requests and serving out the requests. Application will serve to the web server, application layered logic. And there is attacks happening here. In fact, a big one. This is a place for like Java. So Java frameworks. Java frameworks could live here. And so a big one is called struts. And the Equifax breach was done because the application layer, the framework used, the Java struts framework, was out of date. And it was able to attack. So the attack can come through the web server, and there'll be some logs of it, but it could land on the application server side. And of course, if it gets really bad, it could be a firewall here, it could be IDSs here, hopefully to catch that. And then you also have database servers. So there's a server back here that's going to create logs, and there could be a backup server too. And there could be actually entries in the database itself, depending on the attack. Type of attack, you might have certain things in the database that could be corrupt. There are injection commands, things like that, that might end up getting written here. So, and don't forget too, you might have a load balancer here also in play. Now, the load balancer is using session-based, that the session token could be handy to help you figure out where it landed. So, a lot of moving parts to consider. And not just that, if you're dealing with cloud, you also have some forward caching servers. Now, these are probably not going to be too valuable. There could be some logs here too. And what a forward caching server is. There are parts of the website. So you go to an Amazon page, there are static things. CSS, for example. We have CSS, some basic HTML, images, things that are static that don't change. It could be like the Amazon logo or the company logo, things like that. And these are actually a lot of times served out from forward caching servers based on the geographic IP. And what that does is, um, so we've all been there. You open up a browser, you want to go to a certain site, and if you have to wait 3 or 4 seconds, you start to get impatient. So what this does is this content, which is static, is pushed out to forward caching servers. And based on your GeoIP, your IP address, it'll find one close to you, and it will start pushing out that stuff immediately. So as a end user, where you really start seeing the company logo, start seeing stuff, and behind the scenes, maybe the 2 or 300 milliseconds later, the web content pipes in, and then application logic kicks in based on things that it may be like a session token, like your shopping cart, cookies, things like that. And you're getting pushed from the application layer up through the web layer. So you have things like cookies, you have, of course, session tokens, but this is a way to kick off a quick response to get that sort of happy end user. So, um, yeah, this is the challenges here. There's a lot of different moving parts here. And if you're dealing with cloud, you might need to consider the fact that you might need to have some cloud experience. Um, Definitely leverage on any security operations center or SOC or the DevOps center, things like that. Now, again, these are busy individuals, and if you're the security professional for the company, you might just need to do your best to find time to get, Q&As from certain parts. So this is not too different from, again, just investigating network attacks in general, but we're going to look at some things here, and this is using what type of stuff is coming in that indicates a web attack. Now, not all this is a web attack. Or DDoS could happen to a lot of different servers. Suspicious activity is definitely one. Um, Error messages, things like that. But more important is what type of threats are we looking at here? So um, there's some big ones here, and I have some really good resources to look at. The big ones you want to look for, though, is cross-site scripting. Cross-site scripting is going to be a huge one. And probably the big one, of course, is ejection. 2 and 3 are ejection flaws. Those are the big ones. Now, directory transversal is one that could happen, but most times a web server should not allow that, but it could be misconfigured server, and we'll look at that. Buffer overflow is one. We have something called fuzzing here. Um, and this one's a large one. Screen misconfiguration. This is the fact that the user, the attacker, could be sort of probing the system, looking for any misconfigured stuff. And this is an example where if a web server allows directory transversal and it shouldn't. Broken access controls, big one. Now, denial of service is one that's sort of a network attack, so I'm leaving it out for now. Log tampering, also probably network, but sometimes log tampering means sending in maybe like a cross-site script to stay in the log. So and hopefully you don't have this one, insufficient logging and monitoring. That's going to make your life hard. So we're going to focus on really SQL injection and cross-site scripting. These are the ones that initially will come over and you can see indicators of an attack. These other ones, sensitive data exposure, that's going to be tough. Unless you do your own audit as a company for that, you're not sure what is happening here. A big one for that, and I'm going to bring this up here, we talk about web attacks, is the API, Application Programming Interface. And how does API play into here? So let's go ahead. I'm going to go ahead and delete this, turn that off. Bring in blue here because we have a component here we need to deal with, and that is our mobile app component. What the mobile app will do is it acts sort of like a forward caching server in a way, right? We have a lot of the assets, graphics, things like that on the app. So you got this cool app where you can order stuff from your mobile device. But what it does is it might talk sometimes to the web server, but actually it's going to hit APIs on the application layer. These APIs, I know this isn't really a web-based attack. This could be a weak point. And what happens is it's an API. API has got regular URL. You could take what would be, if you monitor the mobile traffic, you can see that it hits certain API URLs. You open those up in a regular browser or use API attack tools, and you use a basic computer to forego the mobile app and just directly interact with the APIs. And this is how you get Um, in broken access controls, you get security of data, and that leads to sensitive data exposure. Could lead to, and of course, that also talks about broken authentication, things like that. So uh, that's a huge deep hole there. I don't want to get into, but something to consider is APIs. So, all right, there's more here. XML entries and so on, captcha attacks. Um, the first one's on that first slide is this. So, um, how do you investigate all this stuff? First off, information about the attack. Chances are, if it was caught by an IDS, there's going to be some great evidence there you want to pull from. Um, but we want to definitely collect logs. This is from the any web server, app server, database servers, firewalls, any type of security monitoring tools. Um, again, and then verify these or integrity of these logs, and then make a copy of them. You don't ever want to just start parsing or editing the main logs. Analyze the working copies, and you look for indicators of compromise. So yeah, clear that out there. Now, before you start digging into that, it's important to understand, of course, what we're dealing with. And so before we jump in and talk about what to look for, understand the architecture here. And you can see all my scribble. There's two ones here to look at, and of course is the IIS. This is Microsoft's um, IIS, and definitely want to use their current documentation or documentation matched to the version of IIS running on the victim machine. We'll call it victim machine here. Um, Unfortunately, if it's really old, that could mean that the logs are handled differently. Also, you want to look for how any configuration files for logging. Something to consider. Not everyone's might use just out of the box logging. They might make some changes. It could be rolling logs, it could be remote logging, which is actually smart. Um, things like that. So look for the configuration or ask about the configuration. This should be known hopefully from any DevOps, SecOps. What's the configuration for logging and where those logs at? And that's going to be your first key to help you get there. And understanding the architecture, how it works, and where and so we have the http.sys. So there you go. We have a .sys file. Uh, how the web server core native modules and so on works. So textbook covers this pretty good. And then also another thing is about the log file itself. This is an example of an IIS log. What do these fields break down to? Again, not everything is going to be of value. Um, like the client IP address could be definitely right. User agent could be one. The refer field, things like that. So they might or may not be of value. Time taken might not be a big deal. This might help you later on. The idea is to thin out. Again, as we look at collecting logs, all right, we look at the funneling of them. We collect all the logs, we dump them in the funnel, and then we refine that and get just the fields we want. And then with the fields we want, then we query for certain indicators for like cross-site script or injection attacks. So keep that in mind. Understanding the underlying architecture, but not just that, where the configuration files are at and how the logging is configured. Also how the system is configured too. The other one in here we're going to play with, of course, is Apache. So we can see here how logs are, what is logging set. We have access log, log rotation is a big one, pipe logs, virtual hosts, other login files, and so on. And the book talks about this too, but I'm saying maybe just a generic overview of how Apache works and how its logs are looked. So we have access logs here. It could be under this location. It could be under Debian. So this could be on the different than this is a different aspect than slightly different than Microsoft. Microsoft could be what version of Windows and what version of IIS was the web server running. That might change how the logging's done, but your event viewer is going to be your main thing to pull those logs out. Apache, of course, what version of Linux is it running? Could change the location. It's not a big deal, but just make sure you again understand the underlying architecture, include what operating system is running, help you find those logs. And of course, IDSs. There's a ton of these. The good part is these usually have some sort of detection, either signature anomaly detection or stateful protocol analysis, whatever used to match the attack. There will be some alarm files. There should be incidents attached to those. And what I didn't talk about, which I think I mentioned previously, was web app firewalls. We have regular firewalls that sit and handle packet use, but we actually web app firewalls work higher up the OSI model, up the chain, where uh, a standard firewall will look down at the packet level. But the web app firewall will look at the application layer and see what type of application it is, and it might block certain things. And of course, I think I mentioned this before too. Before we get all this, yeah, I have a bunch of that scribble. One component I think about here, of course, is you might have something like FireEye or some third-party, so web app firewall in place. Uh, Fire is a big one, something that sits out in front and monitors all your traffic. Amazon might offer some kind of stuff like this for cloud-based. Um, so just keep that in mind. There's a lot of stuff in play here, and you always look at the documentation that comes from the uh, the type of server it is, Apache or IIS, and you can it might help you guide about what type of logs you should be looking for. All right, so a lot of work there, gathering logs, and maybe you start parsing them, but we then look at indicators of attack. So this slide right here. So something to help you with this. Now the textbook goes into this, as well as the lab. It does a good job of pinpointing some stuff. I want to show you something called OWASP, which if you've taken any of my classes, other security classes, this is a fantastic tool, and this is going to help you say, okay, we think maybe it was an injection attack. One of the most common ones, definitely, um, or cross-site script, which I think is now under injection. So yeah, it is. So cross-site script, they doesn't change. They change every few years, but you can see we have cross-site script. So injection attacks are one of the bigger ones. And you can say, okay, what type of injection attack is, how to prevent it, and here's some example attack scenarios. This could be what the string looks like in the log file. So you can see we have this sort of crazy, here's an example of the attack right there. So we have a comment indicator there. So there's a lot of stuff here, injection attack, attention prevention, SQL injection prevention. These are good to help fix the issue, which is great because you can feed this back to maybe an experienced team and say, well, I'm using this to help me figure out the attack itself. What kind of misconfigurations I'm looking at. Here's some scenarios, testing for error codes. So on insecure design, that's a real bad one. There you go. Injection prevention in Java, query optimization. So you can see where a lot of these cheat sheets might have examples of good examples you can use. So you probably will end up building some notes on that. And so we'll look at here is the lab itself. This is very similar to the previous lab. This is using Splunk, but you can see here we're looking for specific things. In this case, we're looking for a cross-site script attack, hence the script indicator. Now, a misconfigured front end, web front end, or application layer is allowing anyone to send whatever they want. If you've been to a website, you try to put in like maybe a colon or put in a bracket like that, and it doesn't allow it. Either it takes it out. That is smart. That's sort of filtering out the user input, and which is good. But there are a lot of ways around it. They can do some encoding and so on. So you can encode the bracket and not just send the bracket in because web servers will de-encode. They can handle encoding. So it's not uncommon to see something like this, %3c, %2, in place of the script. So keep that in mind. Encoding can be a big thing. But the good thing is with Splunk, again, you can feed in. We're looking for this indicator here, and you can see right off the bat, we start pinning out what the attack was. So again, one of the biggest jobs, of course, is gathering the evidence. And so you go through the process, you funnel down. Spelunk's great for this. Get all the logs. You thin out the fields you want. I want host, source, and source type maybe, or just these are the fields I need. And then in this field here, this shows an indicator of attack, which I can send in a query. I can put that into several logs, and I can correlate the events. Of course, it comes with the IP address, date, time, and you can see here here's some encoding values that could be used for normal characters that are used sometimes in attacks. Um, so the lab's great at doing this. It's gonna have you walk through and figure out how to apply these filters to, an example, a cross-site script here. So there's a lot of loading here and so on. So I don't walk through the whole lab, but the lab will walk you through, and here we can see another script attack. So it's important to document what log file is pulled from, the IP address, date, time, things like that. One example too is back to the network one. What is the date time for? Is it local date time? Is it UTC? So you need to do some conversions there just to produce your report. One of the big ones too is did the attack work? So you might get alarms from IDSs showing attack. A certain attack string has come through. It was detected. That was blocked. But it never actually kicked off because it was mitigated somewhere down the chain. There was proper input filtering, things like that. But if it didn't, um, this is going to be evidence you would use to go back and say, how can we fix that? And this is where, how can we prevent it? So this would be a great thing to help with more the non-criminal side is how can we, fix our system more just the, instant response team. Yeah, we found this issue here. Here's some cheat sheets here, specific things you can use for like a .NET developer. Here's what I want you to do. Here's some examples. Do parameters.add, do parameter checks, or for Java, to prepare statements. So, and the thing is, we're going from speaking cybersecurity forensic side to speaking developer language, and it's going to help you, um, close the deal. As in, I did my analysis. Here's the attack came from. Here's how they got in. Here's how you can prevent it. Now, again, from a full-on um, criminal side investigation, this might not be needed, but this is a great tool to have. This, in my experience, a lot of the web-based attack stuff will come in, and it's going to be more for really more for your instant response team. So having those tools available to you can provide those are fantastic. So to wrap it up here, there's no lab for this one. It's the Splunk walkthrough. It's fantastic. Let's look at the lab documents here. And I walked through the lab myself. It's a lot of steps, but you can see how Splunk, a tool you might need to be very handy after you collect the log. So again, understand the underlying systems that came under attack, underline the attack path, and this is going to reflect back up on the architecture, um, and then log files. What can you say? This is the this is the lifeblood of any network-based, application-based thing. Log files are going to be key. IDS is going to be helpful if it's there, and then of course, take the log files, you know, um, correlate, filter, refine, uh, pull out indicators of attack and correlate them, and you can build a timeline of the attack. So, anyways, that wraps up this little lecture here about web attacks. Thank you for watching.